Hello everyone, my name is Sarthar Singh and we are students of Group 8 from Chemical Department, and today we will discuss the role of pressure and temperature sensors in our daily lives and across various industries. These sensors are everywhere, from household appliances to medical devices, where they help monitor and control critical parameters that directly impact our safety, comfort, and productivity. Next slide. Let's begin by understanding what these sensors do. Pressure sensors measure the force exerted by liquids or gases, which is crucial for monitoring hydraulic and pneumatic systems. Meanwhile, temperature sensors detect the thermal energy of a system, allowing precise control over temperature in many settings. These sensors have countless applications across a wide range of industries, from consumer electronics to industrial automation. In daily life, they are in our HVAC systems, kitchen appliances, and cars, helping to maintain comfort and safety. In industries, they are vital for quality control, safety, and operational efficiency, particularly in manufacturing, automotive, and medical fields. Next slide. Early versions of these sensors relied heavily on mechanical principles. Mechanical gauges for pressure, like Borden tubes, and bimetallic strips for temperature, were some of the first devices used. These often featured analog displays and automated measurements, provide a basic yet effective way to monitor values. However, these early mechanical sensors had limited accuracy. Their precision and sensitivity were constrained by the design, which doesn't match the capability of today's advanced digital sensors. Next.
Okay, so let's start with how sensors improve the efficiency of home appliances. In refrigeration, sensors constantly monitor the temperature and pressure, which keeps the cooling system running smoothly and helps prevent breakdowns. When it comes to washing machine, sensors measure water levels and control heating, which means clothes get cleaned better while saving energy. And in ovens temperature, sensors maintain the right heat levels, ensuring the food cooks evenly every time. Now let's talk about how sensors are used in cars or automotive applications. For engineering monitoring, sensors keep track of oil pressure and coolant temperature, helping to detect any issues early so the engines run efficiently. In tire sensors check tire pressure to ensure they are properly inflated, which boosts safety and improve fuel economy. And finally, climate control sensors adjust the air conditioning and heating to keep the cabin comfortable for everyone inside. Thank you.
So, in medical equipment, pressure and temperature sensors basically play a role in keeping the patient safe and well monitored. In blood pressure monitors, sensors measure how much pressure the blood puts on artery walls. And in incubators and ventilators, they help control the pressure and temperature to create a stable environment for babies, primarily. During surgery, they ensure tools like scalpels and cauterizers work safely. And in patient monitoring, sensors track vital signs non-stop so that if healthcare providers can react quickly if something changes. Next slide. In the chemical industry, pressure and temperature sensors are key to storing and conducting reactions. For example, in storage tanks, they help ensure that chemicals are stored safely. In pipelines, they help prevent leaks. In reactors, they help ensure that the reactor reactions are carried out safely. And in distillation columns, they help ensure that the gases and liquids are separated efficiently. Next slide. So basically, in all of these pressure and temperature sensors, the primary chemical engineering concepts used are thermodynamics, material science, fluids, and instrumentation and control, as well as process engineering. Thermodynamics deals with heat transfer and phase changes. Material science is usually for choosing the correct material. Fluid mechanics is related to pipe flow, and instrumentation is primarily dealing with optimizing processes and choosing the correct systems. So yeah, next. Yeah.
Next slide. So, manual blood pressure measurement devices like sphygmomanometers are essential in healthcare for precise blood pressure monitoring, comprising an inflatable cuff, pressure gauge, and a stethoscope. These devices work by inflating the cuff on the upper valve to temporarily stop blood flow. As the cuff deflates, the provider listens for the pulse to record the pressure. This manual method is often more accurate than the automatic devices, which particularly for patients with high blood pressure and allow providers to detect any unusual pulse sounds that may indicate underlying health issues. Next slide, please. So a manometer is a simple tool for measuring pressure by comparing fluid or gas pressure to atmospheric pressure. It's used in everyday settings like checking car tire pressure and ensuring applicants like furnaces function properly. At home, manometers help maintain safety by measuring gas pressure in natural gas lines, preventing leaks, and supporting safe appliance operation. They're also a part of HVAC systems optimizing airflow for comfort. Next slide, please. So the board on top tube is a common pressure sensing device used in both industrial and household settings. It has a coiled C-shaped tube that straightens as pressure increases, moving a pointer or dial to display the reading. The industrial application of this tube could be to monitor and regulate pressure in equipments like pressures, pumps, and HVAC systems, essential for safe operations. And household use could be to monitor tire pressure, check gas pressure for appliances, and measure water pressure in plumbing, contributing to safety and efficiency. Next slide, please.
So thank you, Shantanu. So coming to thermometers, thermometers are really versatile temperature measuring tools. They come in liquid and glass type of thermometers, which are basically classic thermometers, which contain a liquid that moves as the temperature changes, or be it the digital thermometers, which use sensors and detect temperature changes and display on them on screen. Uh, uh, the real life uses of them include like measuring temperature, uh, or say measuring the indoor outdoor temperature, or even in cooking to check if the food is correctly cooked or not. Coming to thermocouples, they are basically devices used in industrial level. They consist of two dissimilar metal wires joined end to end, which generate a voltage corresponding to the temperature difference. Uh, and They are very useful for applicate, applicate operating in high heat environments. Real life examples include they are used in factories and power plants, where they are used to measure extreme temperatures, and they are also used in gas stoves and water heaters at home, which prevent heat from flames and shut off gas if the flame goes out in gas stoves, and they are a very essential safety device. Coming to thermistors, they are a pressure and temperature control device in electronics and household devices. Uh, Basically, they are small temperature sensitive resistors that change resistance based on the temperature. They come in two types, NTC and PTC. NTC, basically, they decrease their resistance as the temperature goes up, and PTC, positive, uh, they increase the resistance as it gets hotter. Um, they also are used in various fields of life. They are used in digital thermometers. They are used in car dashboards, which monitor the engine temperature and gives us the alert if it's overheating. And they're also used in fridges, so that the food stays fresh and the energy bill stays low. And they keep our gadgets, car, and appliances safe and overall efficient. So thank you guys for the presentation. This was all from Group A. Thank you.